Hello students, hope your preparation is going well. Today we will discuss important terms and problems with all complete theory in ray optics. We will start from plane mirror. Okay. So what is to be studied in ray optics? The ray optics, that is geometrical optics, is studied as reflection of light, laws of reflection, definitions, object image. Okay. So let's start one by one. Geometrical optics. It is divided into two categories. First is ray optics and another is wave optics. And another is wave optics. The light behaves as a ray when wavelength of light is negligible in comparison to characteristic dimension of object. Then light behaves as a wave, light behaves as a ray, and we study ray optics. When wavelength of light is negligible in comparison to characteristic dimension of object, then light behaves as a ray and we study ray optics. Okay. And when wavelength of light is of the order of size of obstacle or aperture, then light behaves as a wave and we study wave optics. Dear student, in ray optics we will be studying the phenomena. If we broadly divided ray optics, we will study two phenomena. One is reflection, another is refraction. Okay. Reflection of light and another is refraction of light. In reflection of light we will be studying reflection from plane mirror and reflection from spherical mirror. which will be again classified into concave mirror and convex mirror. And when we will talk about refraction of light, we will study refraction from plane surface and refraction from curved surfaces. Where we will study about lens and all these things. And finally, we will discuss optical instruments. Okay. So let's start reflection of light. So dear student, what is reflection? The general meaning of reflection is, in term of light, it is a phenomenon of rebouncing back of majority part of incident light in its original medium. Phenomenon of rebouncing back of majority part of incident light in its original medium is called reflection, because this phenomenon is a phenomenon of single medium. So velocity, wavelength and frequency will remain same for incident and reflected light. Okay. And laws of reflection are valid for all types of mirror, whether plane mirror or spherical mirror, whether smooth surface or rough surface, or whether plane mirror, thin mirror or thick mirror. Okay. So let's discuss some important definitions and terms. What is light? Light is such a thing with the help of which we see the object. Okay. And dear student, what is ray of light? A ray of light simply indicates the direction of propagation of energy. A ray of light simply indicates the direction of propagation of energy. Indicates the direction of propagation of energy. What is beam of light? A bundle of light ray is called beam of light. Bundle of light ray is called beam of light. And what is pencil of light? A narrow beam of light is called pencil of light. A narrow beam of light is called pencil of light. Okay. Now, dear student, let's see some more definitions. What is object? The point of intersection of incident ray. The point of intersection of incident ray is called object. It is always defined with the help of incident ray. Okay. Minimum 2 incident rays are required to define an object. Object is what? Point of intersection. Point of intersection of incident ray is called object. Remember, the diverging incident ray forms real object. Diverging incident ray forms real object, while converging incident ray forms virtual object. Minimum two incident rays are required to define an object. Okay. And what is virtual object? Virtual object is a object where object is there, but at the location object light is not there. Okay. Now, dear student, let's talk about the image. In the case of reflection of light, image is defined with the help of reflected rays. And in the case of refraction of light, image is defined with the help of refracted rays. Okay. And how do we define the image? The point of intersection of reflected rays in case of reflection, or point of intersection of refracted rays in case of refraction, we define the image. So it is defined in case of reflection, because first we will study reflection. So we are talking for reflection. Point of intersection of reflected rays is called image. The converging reflected rays forms real image, while diverging reflected ray forms virtual image. Converging reflected rays forms real image, and diverging reflected rays forms virtual image. Minimum two reflected rays are required to define an image. Both real and virtual image can be seen. Both real and virtual image can be seen, can also be photographed, but virtual image cannot be obtained at the screen. So this is what about the image. Now, dear student, let's talk about the laws of reflection. The laws of reflections are very simple. There are two laws in reflection. First law is angle of incidence is equal to angle of reflection. All the angles are measured with respect to normal. And the second law is at the point of incidence, incident ray, reflected ray, and normal to the reflecting surface, all three lie in the same plane. That is, they are coplanar. Okay. There are two laws. First law, let's see this diagram. Suppose this is a plane mirror, and what is plane mirror? And what is mirror? A mirror is any reflecting surface that reflect majority part of incident light in the same medium is called mirror. If surface of mirror is plane, it is called plane mirror. If surface of mirror is curved, it is called spherical mirror. Okay. This is mirror. This is normal. And this is reflecting surface. This is incident ray. And this is reflected ray. This is incident ray and this is reflected ray. This is angle of incidence. This is angle of reflection. Okay. So dear student, the first law is what? Angle of incidence is equal to angle of reflection. This is first law. And what is second law? At the point of incidence, incident ray, AO is incident ray and OB is reflected ray. At the point of incidence, incident ray, reflected ray and normal to the reflecting surface, all three lie in the same plane. Okay. At the point of incidence, incident ray, reflected ray and normal to the reflecting surface, all three lie in same plane. That is, they are coplanar. If we write laws of reflection in vector form, dear student, let if EI cap equal to unit vector in the direction of incident ray, unit vector along incident ray, and ER cap equal to unit vector along reflected ray and N cap equal to unit vector along normal to reflecting surface. So dear student, we will be using mathematics concept which we study in mathematics vector. Okay, let's see. When three vectors are coplanar, this is the essential condition product of cross product of two vector with dot product of third vector should be 0. This is the essential condition for three vectors to be a coplanar vector. Okay, EI cap cross N cap dot ER cap equal to 0 or ER cap cross N cap dot EI cap equal to 0. The essential condition for three vector to be a coplanar vector is that Cross product of two vector with dot product of third vector gives us zero result. Then vectors will be coplanar to each other. Okay. This is the essential condition for three vectors to be a coplanar vector. Now, dear student, I am writing the equation of laws of reflection in vector form. That will show you the actual meaning of the reflection. Okay, what happens in reflection of light? This is laws of reflection in vector form. This is unit vector along reflected ray. This is equal to unit vector along incident ray minus 2 EI cap dot n cap dot n cap. Here is no dot, okay. So this is laws of reflection in vector form. ER cap equal to EI cap minus 2 EI cap dot n cap and n cap. Okay, this is laws of reflection in vector form. Okay. Here ER cap is what? Unit vector along reflected ray. EI cap is what? Unit vector along incident ray. N cap is what? Unit vector along normal to the reflecting surface. Okay. So dear student, we can apply this equation for solving, for getting equation of reflected ray. Okay, let's see. Let us assume a plane mirror is in XY plane. Let us assume. And also assume equation of incident ray. Equation of incident ray falling on plane mirror is xi cap plus yj cap plus zk cap. This is equation of incident ray. Now we have to find equation of reflected ray. Find equation of reflected ray. Now dear student, the problem is very simple, but this problem is very important because this problem will completely make you to understand the process of reflection of light. Okay. Dear student, what is given? Equation of incident ray is what? Xi cap plus yj cap plus zk cap, where I cap, j cap and k cap are unit vectors along x, y and z direction respectively, and n cap is given as k cap because plane mirror was in xy plane. So dear student, from the concept of vector, we can easily find unit vector. What is unit vector? Vector divided by magnitude of vector. Okay. So dear student, what is unit vector of incident ray? This is xi cap plus yj cap plus zk cap divided by under root x square plus y square plus z square. Okay, this is unit vector along incident ray. Now we will be using laws of reflection vector form, okay, to solve the problem. Now this is unit vector along reflected ray. We are using xi cap plus yj cap plus zk cap divided by under root x square plus y square plus z square. This is EI cap minus 2 EI cap xi cap plus yj cap plus zk cap divided by under root x square plus y square plus z square dot n cap multiply by n cap. Okay, we know I cap dot k cap is 0, j cap dot k cap is 0 and k cap dot k cap is 1. Okay, so this equation will give us xi cap plus yj cap plus zk cap divided by under root x square plus y square plus z square minus 2. This will be z k cap because I cap dot k cap is 0, j cap dot k cap is 0, k cap dot k cap 1 and z into k cap. Divide by under root x square plus y square plus z square. Okay. Now we will be taking under root x square plus y square plus z square as LCM. Okay. This will become xi cap plus yj cap plus zk cap minus 2zk cap. Okay. So after solving this equation, we will get this er cap equal to xi cap plus yj cap minus zk cap divided by under root x square plus y square plus z square. So dear student, how do we define the vector in the chapter of vector? Okay, any vector can be defined as magnitude of vector multiplied by unit vector. Okay, so dear student, in our question, equation of reflected ray can be written as xi cap plus yj cap plus zk cap divided by under root x square plus y square plus z square multiplied by magnitude, that is under root x square plus y square plus z square. Cancel this under root x square y square plus z square by under root x square y square plus z square. So final equation of reflected ray, equation of reflected ray in our case is xi cap plus yj cap plus z. This was minus zk cap. So dear student, what you observed in case of reflection of light? Since equation of incident ray falling on plane mirror in xy plane was xi cap plus yj cap plus zk cap, and you got equation of reflected ray through the same mirror in xy plane xi cap plus yj cap minus zk cap. So what happened in reflection of light? In case of reflection of light, remember very important phenomenon. The direction of component normal to the reflecting surface gets reversed in case of reflection of light. Okay, which component? The direction of component normal to the reflecting surface gets reversed in case of reflection of light. Had the mirror will be in yz plane, the x component will get reversed in direction. Had the mirror in xz plane, the y component will reverse its direction. So dear student, if we keep three successive perpendicular plane mirrors in xy, yz and xz mirror, xz plane, so what will happen? All the three directions will get reversed. Okay, so we will get anti-parallel ray. Okay, anti-parallel ray. So equation of incident ray in that case, if xik plus yjk plus zkk, then the final equation of reflected ray in case of three perpendicular plane mirrors will become what? Minus xik minus yjk minus zkk. Okay, so what the three mirror will do? The three mirror will make the incident ray to be anti-parallel. Okay, this is very important phenomenon. So you must remember what reflection do. In the plane of the system, reflection do not do anything. Okay, so in case of reflection of light, only direction of component normal to the reflecting surface gets reversed. Okay, so this is what happens in case of reflection of light. So dear student, now we will see some important properties about the image formed by plane mirror. Okay, so let's see. Characteristic of image formed by plane mirror. Characteristics of image formed by a plane mirror. Dear student, when we are saying plane mirror, we are talking about the thin mirror. Okay, See, for plane mirror, curvature is 0 and curvature is inversely proportional to radius of curvature. So dear student, radius of curvature is infinity and focal length equal to r by 2. So focal length equal to infinity and power equal to 1 by f. So power of plane mirror is 0. Because power is 1 upon f. So dear student, this is all about the curvature, radius of curvature and power. Now see the second result. Dear student, a plane mirror forms virtual image for real object and real image for virtual object. Okay, a plane mirror may form both the type of image, that is real image as well as virtual image. For real object, a plane mirror will form virtual image, and for virtual object, it will form real image. Okay. See, suppose this is a plane mirror. Suppose this is a object. Suppose this is incident ray, which is normal. If this is incident ray, then in case of reflected light perpendicular, this is also reflected ray. Since angle of incidence is equal to angle of reflection, let's draw this is another incident ray. This is normal. This is angle of incidence. And now this is reflected ray. So this is angle of reflection. Okay. This reflected ray and this reflected ray is of diverging nature. So they will never intersect, okay, ahead. So what we are doing, we are projecting them backside, okay. So dear student, what we are observing that as if these reflected ray are coming from this point, okay. So this is image. For real object, the plane mirror forms virtual image, okay. This is real object. Why real object? Any object in front of mirror is real object, or any image behind mirror is virtual image, okay. Whether object or image, if it is in front of mirror, it is real. Whether object or image, it is behind mirror, it is virtual, okay. And one more important thing is that a plane mirror, whatever is the perpendicular distance, suppose this is D. Whatever is the perpendicular distance of object from mirror. Dear student, whatever is the perpendicular distance of object from mirror, same is the perpendicular distance of image from the mirror. Okay. In case of plane mirror, object and image always located at the perpendicular bisector to the mirror, and distance of image, perpendicular distance of image from the mirror remains same is that of perpendicular distance of object from the mirror. This is very important point, that perpendicular word, okay. And see, look at the case of this is virtual image. See, how do we define the virtual object? The converging incident ray forms virtual object, okay. Angle of incidence remains equal to angle of reflection. This is incident ray and this is also incident ray. We are projecting these rays. This is virtual object. This is virtual object. Now, since angle of incidence equal to angle of reflection, so these rays, this is normal, this is normal. These rays will intersect at this point. So what you observe? In case of virtual object, image is real because these rays are converging. Converging reflected ray converging reflected ray forms real image. Okay, this is real image. This is virtual object. Okay, so what you object? A plane mirror. A plane mirror may form both the type of image, real image as well as virtual image. For real object it forms virtual image, and for virtual object it forms real image. And whatever is the perpendicular distance of object from the mirror, same is the perpendicular distance of image from the mirror. Okay, always remember, object and image always remains located at the perpendicular bisector to the mirror. Okay, object and image always remains located at the perpendicular, at the angular, object image always remains located at the perpendicular bisector to mirror. Okay, so dear student, this was all about some important points for reflection of light. Now some important characteristics we will discuss in next lecture. Okay,